last time we talked, we gave a little description visually, and we also talked verbally about what it meant for a limit to converge to some value L as x approaches a. Let's remind ourselves what this means. This thing right here, the limit, as x approaches a of f of x, all we are saying is as x gets really close to a, really, really close to a on the x-axis, then, well, this doesn't equal anything yet. We are just trying to see where f of x goes. Then, where is f of x going? Right? That's what we're saying verbally. And graphically, we show that as we take points that get closer and closer to A on our domain, we are going to see what starts to happen on the function. Where are the heights going? The function values going. And whatever that thing gets really close to, whatever the function values get really close to, that is what we call L. Okay? Keep in mind that we're not coming really close to it from one side. We're coming close to A from both sides, right? We are coming in from the left-hand side and the right-hand side. But the point is that why can't we just go in from one side? Well, the limit only exists when we come in from both sides. But what we do is we actually analyze it from both sides separately first. And then if they equal, then we look at both sides together. So this is actually something we call a two-sided limit. But we can look at just the individual left and right-handed limits alone. So this right here, the limit as x approaches a with a negative sign of f of x, that indicates we are coming in from the left-hand side. And if we have a positive right here in the top corner of the number, that means we're coming in from the right-hand side. We're not coming in from both. We're getting really, really close to A from the left and really, really close to A from the right separately. And then if they both equal, then we can take a look at this one. So what does the left-hand limit mean? It's the same thing as x approaches A from the left. Then where does f of x go? And with the other side, it's the same thing. If we approach A, but this time not from the left, this time we're going to approach it from the right. So if there's a negative sign on the top, that means we're approaching the limit from the left hand, approaching A from the left-hand side. And if it has a positive sign at the top, we're going to approach it from the right-hand side. And the two-sided limit exists only when the left-handed limit, which has the negative, equals the right-handed limit. And that's our answer. So what we're going to do now is we're going to take a look at this graph. And we're going to try and fill in the left-handed limit, the right-handed limit, the two-sided limit, and then the function value. So let's go ahead and start with the first one. The first one is the limit as x approaches -3 of our function. So let's go ahead and take a look at our function. And we want to take a look at it as we get closer and closer to -3. So as we get closer to -3, where's our value going to? So let's start with the left-handed limit, all right? We're only going to look at the left side, this first one, okay? So as we get closer and closer and closer to -3, the function values, the heights, get closer and closer to 1, right? So that means that our left-handed limit equals 1. And if we do it from the right-hand side, and we come in closer and closer and closer and closer and closer to -3 from the right-hand side, we end up getting closer and closer and closer and closer to 1. So the right-handed limit as well equals 1. All right, now, because the left-handed limit and the right-handed limit equal the same thing, then the two-sided limit does exist, and it also equals the same value, 1. But now, limits are not the same thing as what the function equals at -3. The function value is actually going to be different. Limits talk to us about what we're getting really, really close to. We might be getting really, really close to -3, but we're never actually getting to -3. What happens at -3 is the function value. And we can see by this bolded dot, f of -3 is up here at 3. So our function value ends up being different to our two-sided limit. Let's go ahead and do another one. As x approaches -1, right? Where's f of x getting really close to? That's what we're saying verbally. Let's do the left-hand side and the right-hand side. All right, so we're doing -1. We're getting really, really close to -1 from the left. Well, our function values, as we get close to -1 from the left side, we get really, really close to 2. And if we do this on the right-hand side, what's happening as we get close to -1, the function values end up decreasing. They go down here to -1. So the left-handed limit equals 2, and the right-handed limit equals -1. So let's go fill that in real quick. 2 and -1. So what does that mean for our two-sided limit? That means it does not exist because the left and right-handed limits need to equal if we're going to have a two-sided limit. This is where we write D, N, E. Does not exist. Now let's take a look where the function value is. F of -1. It's where the bolded dot is at -1. This is open, meaning this is not where f of -1 is. This is closed. This is f of -1, and that happens to be at -1. So our function value ends up being the same thing as our right-handed limit. So go ahead and try the other two on your own and come back to see what the solutions are. They follow the exact same properties as the ones before. All right, welcome back. And as you can see, all of the limit as x goes to 0 of f of x, all the limits equal 0 and the function equals 0 at x equals 0. And on the second one, as x approaches 2, the limit as x approaches 2 from the left-hand side and the right-hand side both equal 0. So the limit, the two-side limit exists, but the function value is different there because the bolded dot is somewhere else. Keep in mind that the limit is what we see when we are approaching in a value, and the actual function value is when you are at the concrete x equals that number. And that's it. Next time we'll talk about another technique on how to solve limits, but that's all we have for graphing.